Hello, Precalculus student. This video is for Chapter 3.7, Part 3. We are looking at sketching a rational function, meaning if someone gives you a formula, you have to find all these characteristics of this rational function, including asymptotes, x-intercept, y-intercepts, and behavior, and then sketch the graph. So again, it's a sketching, so it doesn't have to be exactly. So these are the procedures that you usually will follow. First is find the y-intercept. There should be one y-intercept. What you do is you set x equal to 0 and then find the y-intercept. And then you factor the numerator and denominator y because you want to find the factors that is not common to both the numerator and denominator and solve each one to find the x-intercept. So y-intercept, x-intercept, but only those that are not common with the denominator. You also use the multiplicity that you find from the x-intercept to determine the behavior of the graph at these points. So if the multiplicity is odd, it pass through it. If it is even, then it bounces back from it. And then we look at the denominator's factors. And in the denominator, this would be the vertical asymptotes because for factors not common to the numerator, those are vertical asymptote. You also note the multiplicity. If the multiplicity is even, both sides of the vertical asymptote goes to the same direction in the infinity or negative infinity. And then lastly, you look at the common factors in the numerator and denominator to find the removable discontinuity by setting each factor to 0. And lastly, you find the horizontal asymptote, which is the behavior of the graph at infinity by checking the degree of the numerator and the denominator. And then you would look at the behavior of the graph close to the vertical asymptote and sketch. Now, so these are all the general step that you can use if your graph cannot be graphed by transformation of the two-kit function. Sometimes if you are to only graph like 4 over x minus 1, you can use the two-kit function 1 over x for transformation. Right? Why? Because this would be a transformation from the 1 over x by transforming to the right one inside of the function x minus 1 is right 1, and then a vertical stretch of 4. So you can do those. If they cannot be done by linear by transformation, then you would follow those procedures. So first of all, x over x plus 5. So this cannot be done by transformation, so we'll use the procedure. So first of all, x-intercept and y-intercept. So y-intercept first because it's the easiest way to do is to set x equal to 0. Y is equal to 0 over 0 plus 5, right? So that is equal to 0 over 5. That's equal to 0. So that means the y-intercept is 0, 0. X-intercept is to solve the top equal to 0. Numerator equal to 0. So there is no common thing, so we just say x equal to 0. So again, 0, 0. 0, 0 is both the x and the y-intercept. Then we look at vertical asymptote. Vertical asymptote is the denominator equal to 0. No common factor, so x plus 5 equal to 0. X equal to negative 5 is the vertical asymptote. And then we talk about no common factor a lot of times, so no removable discontinuity, right? There's no hole in the graph. The only thing that breaks it up is the vertical asymptote, removable discontinuity. What about horizontal asymptote? We look at degree, right? Degree 1, degree 1. Degree 1, the same as degree 1 in both numerator and denominator. So same degree, we would look at the leading coefficient. This is 1 and this is 1. So 1 over 1, that is y equal to 1 is the horizontal asymptote. Okay, so we are ready to graph. And there's low slant asymptote, of course. So you will graph the vertical first, -5. And then we'll graph the horizontal, y equal to 1, x equal to -5. And then we have 0, 0, right? So there is a kind of hints that on this side, maybe it's like this, right? But we don't know. So we look at the behavior of the graph close to x equal to -5. So you could find what is f of -4. You can find f of -6. That's also okay. But you can also do plug in what happened when x is close to -5 on the positive side. So on this side, what is it? Okay. So we will say y equal to -5 on the positive direction, the right side, right? So -4.999 over -5 positive, what was it? +5, right? So the top is a negative number. The bottom, would it be a negative or positive? If I add 5 by a -5 positive, this is a positive number because this is -4.9 only, right? Less than -5, it is a number that's larger than -5. So if you add 5, it's positive. So the whole thing is negative. So you can see that this goes to when x approaches -infinity, it's going to go to -infinity, pass through 0, and this side would be +infinity. It goes through 0. So that's how we graph it. Second one, the first way we always do is to factor the top and bottom. So x minus 2, so we can detect if there's any common factor, x plus 2. And also during the factoring process, it is useful for us to solve for 0. How do I factor 2x squared minus x minus 1? So AC diamond, -2 and 1, right? When you multiply this, it's -2. When you add them, they're -1. So it would equal to 2x squared minus 2x plus x minus 1. That is equal to 2x, x minus 1, plus 1, x minus 1. Factor totally is 2x plus 1. Oh, yeah, my writing pad is not very good. X minus 1. Okay, so we can write it as 2x plus 1, right? 2x plus 1, x minus 1. Okay, so are there any common factor? There's no common factor. So, okay, so get this out of the way. So let's do y-intercept. Y-intercept is when x is 0, so we plug in 0. 0, 0, minus 1. We don't use this because it takes longer. So 0, minus 1 over 0 minus 4. So that would be -1 over -4. That is 1/4. So y equal to 1/4. So the point is 0, 1/4. X-intercept is to solve the top equal to 0 with no common factor. So we don't have any common factor. So that means 2x plus 1 equal to 0. X is equal to -1/2. We can also do x minus 1 equal to 0. X is equal to 1. So we have two x-intercept. -1/2, 0. And also 1, 0. Right. So now we're going to do vertical asymptote. Vertical asymptote is for when the denominator is equal to 0, excluding common factors. We don't have any common factors. So it's x equal to 2, x equal to -2. Right? It's the denominator x equal to 0. What's the last one? Horizontal asymptote. Horizontal asymptote, we don't look at the factor form. We look at the original one. Degree 2, degree 2, right? Both are degree 2. Degree 2 equal to degree 2. So the horizontal asymptote would be, they go to infinity at the same rate except for the coefficient, so it's 2 over 1. So y equal to 2 is the horizontal asymptote. So we're going to graph it here. Horizontal is equal to 2, y equal to 2. And we have the 2 vertical asymptote 2 and negative 2. Negative 2, oh, x is equal to 2. Yeah. And then we have some intercepts, right? We have a 0, 1/4 kind of here. And then x-intercept would be, we have also 2 x-intercept, right? Negative 1/2, 0, and 1, 0. So there's a small point here and 1, 1, 0. So maybe it's curving. So now, where would the graph look like? So we don't connect it this way. So what would the graph look like on this side? So usually we would look at on this side, does it go to infinity or negative infinity? So let's plug into the formula. Our formula is 2x plus 1, x minus 1. 2x plus 1, x minus 1. And then the bottom is x minus 2, x plus 2. Okay, so let's consider what happened. Let's consider what happened at negative 2 on the negative side. So when x is equal to negative 2, negative, that means on this side. So let's plug in what y would equal to. Y equal to 2 times 2 to the negative 2, negative. Negative 2 on left side, like negative 2.1. And then I plus 1. So basically you plug it in. And then negative 2 to the negative side minus 1 over negative 2 to the negative minus 2. Negative 2 on the negative side plus 2. So what do you see? I have a negative number times a negative number over a negative number times. Is this a negative? Negative 2, negative plus 2 is a negative. So overall, I have a positive number. So this would go to positive on this side. And because at x equal to negative 2 is a odd multiplicity, the factor has odd multiplicity, they don't go to each other. They would go different way. So this would go this way. Okay. So let's see on this side. What about y equal to 2? X equal to 2, positive side. On the positive side. Negative 2, negative, right. So well, I would have y, plug it in, right? 2 positive side. So it's like 2.1 going into the horizontal the vertical asymptote. 2 times 2 positive plus 1. The pen is not working well. 2 times positive minus 1, so the both of them are positive. 2 times positive minus 2, also positive. 2 times positive plus 2, so all of them are positive. So I think on this side is going to be on this going up. And then for this one, you can see that they go different direction because you don't have a. So that would be the sketch for this graph. Now, when you have 2 vertical asymptotes, so there are a lot of possible things that you can have. You can have something like this, where they go like this. There's a lot of different way. Okay, go this way. You can have something like this one. You can have something that is go up. You can have something that, go different direction. But the one that you can notice is because the denominator has x minus 2, x plus 2, you have 2 different vertical asymptotes, but they have power 1. You would know that on the 2 side of the vertical asymptote, they go different direction. So if you know one side, you can pretty much figure out what the other side would be. If this side go to positive infinity, the other side would go to negative infinity. How do I know it's positive infinity? I just pretend that I'm plugging in a number that is really close to a negative 2, but from the negative side, from the left side. So this would be negative 2 point something. I pretend that I plug in negative 2 point something to it.